Hello, everyone. Hopefully, you're all doing well and that you'll finish the overflow lab without too much trouble. We're ready to move away now from the system security. So, if you remember with chapter 1, 2, 3, and 4, we were very much focused on the Linux system, very much focused on the operating system, and then with the buffer of overflow on the C code and how we can attack those kinds of systems. We're skipping ahead now, so I'm moving away from the system stuff onto some of the web stuff. So chapter 10 is where we're going. So it's a big jump, but it's a whole sort of different area, different topic that I'm going to go through. It's very different. It's less about the operating system, less about the shell, and more about web stuff, which means that we have to sort of introduce some new concepts. Some of these will be familiar to some of you. Some of them will be brand new. And so I'll just kind of go through some of the basic ideas that you need. Okay, so with web stuff, so we're talking about web security. So have you ever wondered, why do websites ever lock you out after a certain amount of time has passed? Why do they require you to authenticate again? How do they save the information in your shopping cart? How do they remember your name and password? And how even maybe do they do targeted advertisement? And the answer is a lot of it is to do with cookies. Not everything, but a lot of it is to do with cookies. So then what is the point of cookies? In fact, what is a cookie? That's what we're going to go look at now, is sort of what are cookies, and what do they allow in terms of security? Okay, so part of this concept is the idea of stateless websites, right? So back in the good old days, okay, before cookies, I'm going to say the pre-cookie days, we had just plain old HTTP, and HTTP is a stateless protocol. So what that means is if we look at the example down below, you can take a couple minutes and look at it. What do I have here? I have a client that is your web browser, right? So that's your Firefox, your Chrome, your Safari, your Internet Explorer, whatever your browser of choice is, right? So you got your browser over here, and then and that's on your machine, right? Your desktop machine, your laptop machine, whatever it is, right? That's your browser. Then over on the other side, we have the server, right? And that's the server that is hosting the website. And in our case, in the case of the VM, the server that we have here is Apache, right? And what we do is, you go into the browser, you type in HTTP, which is the hypertext transfer protocol, and what you type in there is your URL, right? Uniform Resource Locator. So you type that in over here, and what that does is that will produce some sort of HTTP request, right? And we're going to talk about two kinds of HTTP requests, the GET and the POST. The example that I'm going to do here is just the GET request, right? So what happens here is that your browser sends a request message. In this case, it's sending you a GET, right? You probably recognize this from when we did Shell Shock, right? You kind of see some sort of request that's being made. In this case, the guest request. The host here is going to be we're going to pass in the URL, and the host is just the location of the server, right? So we send, so the browser, takes that URL, formulates this request, sends it over the internet. Don't worry about how that goes. It's going to get to the server. The server is going to map the URL, so it's going to look at that second half of it, right? So let's look at this URL. The host port here determines the location of the server. The second part here determines the location on the server for the file that you want to bring up, right? The HTML file, for example, that you want to bring up. So it goes onto the server, and it goes through the documents on the server, finds the path, the URL that you need, right? The path and file, sorry, that you need. It sends a response message back, and it sends and sends it over. And we're sending it over TCP/IP. Don't worry about it; it's just over the internet. Sends it back to the browser. The browser takes that HTML file, formats it to make it look like you expect it to look. So the headings are headings, the images show up as images, things are in the appropriate location. And so the browser formats the response and displays it. Okay. The idea with this concept that HTTP is stateless is that the current request, right? So we've sent out this request here. It doesn't know what else has been done on previous requests. So it doesn't know if this browser has actually been to this website before. Has it requested this page before? Has it done anything? It doesn't remember the state, right? So it doesn't know anything about it. That's what it means by it to be a stateless protocol. Okay, so then what is a cookie? Okay, so the cookie, the idea of a cookie is it's a tiny little piece of data, right, that is sent from, again, maybe pause the video and have a look and see if you can think about the answers to this. Okay, so where is the cookie actually sent from? The cookie is sent originally from the server, right? That's the original place where the cookie comes from. It is stored on the user's computer. Okay, and I'm going to show you a graphic in a minute of how these cookies get passed about. And so it's stored on the user's computer, and who's it stored on the user's computer by? It's stored by the web browser. Okay, so the web browser manages those cookies, right, that are being passed around. And it is just a small piece of data. It has a bunch of information. They're named value pairs. It's funny how a lot of things in CS are named value pairs, but that's what we have here too. Okay. Why do we have cookies? Because we want to remember stateful information. So in other words, we want to remember, has a user been here before? Maybe if they've put anything inside of the shopping cart, right? Because think about it, we're not just talking about, oh, today I visited a website, tomorrow I'm going to visit a website again. No, I'm talking about like, I've visited a website, now I've clicked on a link in that website to a different page, but maybe even going from page to page, I want to remember that I looked at that previous page, right? So that's what we talk about here with recording the browsing activity, right? So think about when you go to Amazon, what do you click, right? What are you looking at? And then how does that information get saved? So it knows, right? So it knows next time you visit, oh, maybe you looked at this, maybe you want to continue looking at toasters or something like that, okay? And it's used to remember other arbitrary pieces of information, right? So also things like maybe logins, other things like that that you might be using. So let's kind of look at a visual of how that works. So again, the left-hand side here, I have my browser, my web browser. In this case, I've got Firefox. On the right-hand side, I have the server that is hosting the web pages. Okay, so the browser is going to send that HTTP request, in this case, maybe some sort of GET. When the server sends that HTML back, it also adds in the cookie, right? And the cookie just contains a certain amount of information. We'll look at a little bit of that in a minute. But it sends that back into the browser. The browser takes all those cookies and throws them into this cookie jar. Okay, and it saves them for later. So next time, whenever you visit that website, it's going to load up those, it will send those cookies along, which is what I'm doing over here, right? So, so again, so the first time a browser connects to a particular web server, so you've never been to a website before, you type in, right, let's say you've never been to pacificu.edu before, right? So you type in http www.pacificu.edu. Your computer, it's a brand new computer, it's never been to that website before, it has no cookies about that web server, right? So the first time a browser connects, it has no cookies for that web server. After that, when the web server responds, it will send back a set cookie header that defines that cookie. So now the browser will have that cookie associated with that website, right? So again, here's our browser, we send the GET, the HTTP request, the GET to the server sends back the page to display, but it also, in the HTTP header, will send a set cookie and give it a name value, okay? Just the name of the website, and set it to some sort of value. Okay, or so it's a cookie name to the value which represents the website, which in this case, Firefox will add it now to the cookie jar. Okay. And by the way, one thing, if you really, you've all probably played with cookies, but you can go and look at the amount of cookies that you probably have inside of your web browser. It's almost scary how many cookies you end up with. Anyway, later on, when the browser connects to the same server later, so you went to http www.pacificu.edu one day, you go sometime later, happens is if you use the same browser, you connect to that website, actually even if you use a different browser, but if you connect to that website, the cookie that was created, right, that was sent back by the server on the previous slide, is now going to go to the server contains the name and the value, which the server can then use to connect related requests. It can use that information, right? That was saved on the cookie, right? The domain and the path inform the browser about which sites to send the cookie to. So in other words, when the browser is sending out a request, it looks at all the cookies and it looks at the domain and the path. And the domain is, like we looked at before, the host and port, so www.pacificu.edu, and then the path is like the path of the file. So maybe you're looking at home, or maybe you're looking at curriculum or academics or whatever kind of other files we might have on the pacificu.edu website. Okay. And yeah, like I say, each cookie is just a name value pair. And that is basically the idea of cookies. So I'll talk to you a little bit about same site and cross site. Okay, so let's look at the difference between a same site request versus a cross site request. Okay, now that we've covered cookies, we're going to look at what requests are. Okay, so what do I have here? I have a user. Okay, Lego man user, and I have a browser. Okay, and let's say that they open a tab, right, and they're requesting a page from website A. Okay, so let's say web page A is www.pacificu.edu. Okay, okay. So then what happens then is, in the browser, I send that request, that HTTP request, to the website, and because I'm requesting website A, right, then it's called the same type request because I'm actually going to website A, to the server, to get that, and I'm sending in A's cookies. The website sends that back, and then the browser formats the page to display it, right? Pretty straightforward when it's the same site request. So how could a cross-site request happen? A cross-site request could happen if the page here contains an image or some other piece of information that's actually located on a different server, right? So perhaps the image here is actually located on, for example, maybe Flickr, right? So, Flickr may, I don't know what Flickr is like. Is it like that? Anyway, whatever the Flickr website is. So that is hosting an image that is displayed on the page that I'm going to display on website A, right? So then what we have there is, okay, so the browser is going to request website A, same site request. It sends the page back, contains an image. So then the browser is going to have to go to website B to pull that image, right? Send that request for that image. It sends any cookies I have for website B and sends that back. And so website B is responsible for generating that image versus website A is responsible maybe for generating everything else. Okay, so that's the difference between it, right? The difference here is that I wanted a page from website A, but that page from website A required information from website B, so that becomes a cross-site request. Okay, happens all the time on web pages when we're loading up web pages. Now the issue is that on the server side of thing, not the user, but in the server side of thing, let's just look at server B, right? Website B. So it could have something that's coming sort of a same type request, right? In other words, the user's requested a page from website B. So I know they generally want something from me. I'll send that information back to the user. It's coming from website B. What the server doesn't know is if a request is coming from somebody else that is not from the same site request, right? So in other words, it's somebody from website A, or a user had got loaded an image or a web page from website A, but then that generated a cross-site request to website B, and because of that, it doesn't know. The thing is here, this website B doesn't know where that's coming from. Because it doesn't know where it's coming from, it could be dangerous because somebody can forge the request, right? And if you can forge that request, that is what's going to cause. That's what a CSRF attack is, or a cross-site request forgery attack is. Okay, and we'll look at an example on the next slide. Okay, so let's look at an example where things can go really, really bad. Okay, or in other words, we get a CSRF attack. All right, so we have 3 entities over here, right? CSRF attack requires 3 entities. we got our user, our regular user, the victim, they have a browser, okay? We have a server, which is also a victim in this case. In this example, I'm going to use the bank as a server. And then we've got the attacker's server, okay, which is, again, hosting web pages, right? So both of these servers